Did you ever wonder how performant enterprise-grade diagramming libraries really are? Well, I can't speak for all diagramming libraries, but I can show you how performant JointJS is. I have the YouTube channel visualizer app open here, and this is app that is obviously built in JointJS on the open source version of JointJS to be precise. And what it does, it displays a channel on this nice canvas, gives you a number of cards for every video, and you can drag those around and it shows connections between those videos, between dates, and so on. In this demo that I have opened, there are 9 videos on the canvas along with their dates, months, year, and connection between those videos and associated tags. This might not seem like much, but I'll jump into developer tools so I can show you exactly what we're dealing with here. JointJS, as you probably know, uses SVG as the rendering engine. There are a number of reasons for that. I will link the article that explains all of those reasons below, so check it out. It's in the description. And spoiler alert, accessibility is one of the major reasons why you want to use SVG as a rendering engine for diagrams instead of Canvas. Anyway, this entire app is rendered in SVG, so I'll select it in the Elements panel here, and let me just move the console a little bit up so you can see it more clearly. I will target all child elements in this SVG right from the console here, so you can see exactly how many elements we're dealing with here. I will just reference the currently selected element with $0, and then I'm going to do query selector all. I will use the star selector to target all elements, and let's see how many elements we're dealing with here. 647. So even though this seems like a simple diagram, there are plenty of elements here, and as you've seen by my interactions here, this is silky smooth. There's no issues here. And just to prove it to you, I'm going to jump into performance tab here, and I'll record the performance as I'm working with this. I'm going to move the elements around, and let's stop this. Let's see what we get. I will expand the panel so you can see it clearly, and let's hide the console. If we were to experience any dropped frames, they will be marked with red here, and as you can clearly see, everything is green. There are no dropped frames. We're dealing with the performance of 60 frames per second. But what would happen if we were to work with more videos? Well, let's try it out. I'm going to load more videos from JointJS YouTube channel. On JointJS YouTube channel, we have 16 videos until now, but we are publishing more every week. So if you don't want to miss new videos, well, hit that subscribe button. But let's load those 16 videos here and see what happens. There we go. This is our canvas. It still feels very smooth. Let's figure out how many elements we're dealing with here. I'll zoom this in a bit. Now we're dealing with 1,156 elements. This feels very smooth, but again, I will use the performance panel to prove it to you. Let's record this. Okay, I'll play around with it. Let's do something like this. And here is my performance analysis. Everything is green. There seem to be 2 yellow frames here. Those partially presented frames are not really a performance issue because they probably happened when I was moving the cards around and the connection lines were just jumping from one anchor point to another anchor point, which is not really animated. It just switches from one side to the other side exactly as you want. But still, we're not really dealing with a complex enterprise-grade diagram here. So let's load even more videos, perhaps 100 videos. We don't have those on JointJS channel, so I'll use a different channel here. Once the videos are loaded, we are dealing with much more complex diagram. Well, you can clearly see there are tons and tons of videos here. And let's just present them differently so you can see a bit better. I'll switch to grid view. So now we're dealing with something entirely different. This is a much bigger diagram, and there are many elements here. Well, let's jump to the console and see how many. Now we're dealing with over 6,000 elements on this canvas. And this feels really smooth. Let's just record performance again. All right. I'll zoom in and out, move around. We are dealing with a few partially rendered frames here, but this is nothing major. This app is still running really smooth. Let's try something even more drastic, 170 videos. Let's zoom out. So we're dealing with an exceptionally large diagram with hundreds and hundreds of connected lines. Specifically, we're dealing with more than 11,000 elements here. Let's jump into the performance panel. Let's record. I'll zoom out, move around the diagram, move the elements around. All right. And now let's see what we get. And we do have a single dropped frame. I'm not really sure why that happened, but essentially we are dealing here with a diagram that has more than 11,000 elements, and performance is, well, more than respectable. And just to be clear, this is a vibe-coded app, so there's no performance optimization going on behind the scenes. We're not doing anything special to get more out of JointJS, and there are quite a few things that you can do to actually get more performance or to make this even smoother than it currently is. Well, actually, let me really quickly show you what you can do to make your JointJS app more performant. I will jump into my terminal and I will enter Claude because I already have JointJS MCP server installed here. So I can just very easily ask AI how to improve performance of a JointJS app, and I will get very concrete and specific answers based on the JointJS documentation. Let me quickly show you my MCP servers. JointJS is connected, and if you are working with JointJS, then you should absolutely install JointJS MCP server. Link is going to be in the description below, so just check it out and add JointJS MCP server. It works really well, and it will help you with the development of JointJS apps. So I'll just ask AI, how can I improve performance of my JointJS app? The AI is looking through the JointJS docs for performance guidance, and that is exactly what I want. I want specific advice on what I can do to improve JointJS performance. So there we go. First, you want to enable virtual rendering, which is the biggest win for enterprise-grade large diagrams. This is the configuration that you need to add to your paper scroller for it. And also note that you're going to have to add async true for this to take effect. The second thing you can do is view management and auto freeze. Again, you're going to need async true. Auto freeze true holds render when it's not necessary, and view management removes out of viewport views from memory, which is, well, obviously good for performance. Then we have search graph for spatial queries. This is within JointJS Plus. This will speed up element under drag detection, snap links, UI selection, find cell views in area, and more. Then we have off-screen rendering. This is specific to JointJS 4.2, and you are using the latest version of JointJS 4.2 at the time of recording. If there's a newer version, well, then you should be using a newer version, of course. So this measure mode option will enable you to avoid unnecessary flows. Obviously, very helpful. Then we have batch updates to call less events and avoid redundant re-renders. This is what you should do. Essentially, there are quite a few things that you can do to improve your JointJS performance. And if you want to know specifically what, use JointJS MCP server and you can get advice tailored specifically towards your needs and towards your app. If we apply all of those performance tips to a JointJS app, how big diagrams can we really build? Let's find out. I'm going to switch to a different demo now where all advice we've seen is already applied. And on this app, we are rendering 100,000 elements. And just to be clear, earlier when I was talking about elements, I was referring to DOM elements within SVG. This pretty much translates directly to diagram elements or diagram nodes. So we're talking about the same things here. But on this demo, things work a little bit differently. We have a diagram with 100,000, yes, 100,000 cells, as you can see in the header, but we're not rendering them all because we did apply a device from earlier. We're just rendering elements that are visible. So right now we're dealing with 50,000 nodes on the diagram, and each of those nodes has a link coming out of it, which means that we do get 100,000 elements on this diagram, which is pretty wild. Currently, we're rendering 300 out of 100,000 cells, but we can move around, and this, as you can see, again, is smooth. No issues with that. We can also scroll to a random point, and now, as we're scrolling, number of rendered elements is changing depending on how many we are rendering. Of course, we can zoom in and out, so let's zoom out a little bit. Now, the number of rendered elements is different. It's all interactive. Everything still works really well. And one final piece of performance optimization that we're doing here is once the zoom becomes too far out and there are too many elements to render for it to be performant, you're actually switching the SVG to canvas. That way, we're getting the best out of both worlds. We have the diagram rendered on SVG, but when we hit performance threshold, we switch that to canvas so we can render it smoothly so users can still work with it, move around, zoom in and zoom out, but we're no longer dealing with SVG, rather we're dealing with canvas. So effectively, number of rendered elements right now is 0. Let's open the performance tab. I will record the performance now. Let's scroll to a random point. Let's zoom in. Number of rendered elements is changing, as you can clearly see. This is still working really smooth. Everything is nice. And let's see what the performance graph looks like. Pretty much everything is in the green. We do have 2 dropped frames and a few partially rendered frames. But remember, we are dealing with the diagram that features 100,000 nodes, 100,000 diagram elements. I'll zoom to fit. This is the diagram that we have here. And as you see, you can work with this without any issues. It's smooth. You can zoom in, you can zoom out, and everything is still interactive exactly as you expect from a JointJS powered diagram. So if you wonder about the performance of diagramming libraries, now you know that JointJS can handle absolutely anything you throw at it. You've seen a YouTube channel visualizer where no performance optimization was done that works with exceptionally large number of nodes of elements on a diagram. And we also have this test right here where we're rendering 100,000 diagram elements on a canvas, and it works absolutely without any problems. If you care about the performance when it comes to diagramming libraries, then you should pick JointJS. I think it's pretty clear why. Thank you so much for watching this. My name is Zoran Yambor. I'm a developer advocate at JointJS, and I will see you in another performance video. Until then, happy diagramming.